Welcome to lecture 15. In this lecture, we want to review EIGRP route summarization. Therefore, after this lecture, I expect you to be able to describe and configure EIGRP route summarization. Let's start our today's mission. Now let's see what is route summarization. Cisco's routers are very strong and they are equipped with high-tech CPUs and RAMs. And if you choose the right one for your network, probably you won't confront any performance problems. But it does not mean we as network administrators should not consider the ways which could help us to improve our router's performance. Route summarization is one of these ways which could help us to improve our performance. Consider these networks: 192.168.0.0/24, 1.0/24, 2.0/24, and 3.0/24. Assume that all of these routers are EIGRP routers, and now this router wants to advertise these networks to the neighboring router. One of the ways which this router could use is advertising these networks separately. I mean, this router advertised 192.168.0.0/24, 1.0/24, 2.0/24, and 3.0/24 as 4 separate routes. It is good and applicable, and this router understands about these 4 routes. But instead of advertising 4 routes, this router could summarize all of these 4 routes in a single route like this: 192.168.0.0/22. This route includes all of these routes, and this router, by knowing this only one route, could reach all of these routes. And we could conclude that by route summarization, we could have our reachability and also reduces the size of routing table, and therefore router could concentrate on forwarding process and finding the routes very quickly in the routing table. So using route summarization could help us to reduce the size of the routing table and increase the router's performance. Route summarization could be done in 2 ways: manual summarization and automatic summarization, which is called auto summary in short. Auto summary means that router automatically summarize some routes and advertise the summary row to the neighboring router. But manual summarization means that the network administrator chooses the networks which he wants to advertise them as a summary route. EIGRP, unlike OSPF, could do manual summarization everywhere. OSPF could do manual summarization only at the edges, which is called ABRs, Area Border Routers, or ASBRs, Autonomous System Border Routers. But EIGRP could do manual summarization everywhere you want. And this is one of EIGRP's advantages in contrast to OSPF. Route summarization, either manual or automatic, totally IP design dependent. And if you do not design your IP addresses correctly, you could not summarize your routes, neither manual nor automatic. For example, if in this network you have 192.168.0.0, 1.0, and for example 64.0 in the middle, you could not advertise these 4 routes in a single route, because this 64 breaks your contiguous networks. And if you want to have summary, you could only have these ones by /23, and this router should advertise these 2 routes separately, and you just summarize 2 routes. Therefore, keep in your mind that if you want to have route summarization and use it to improve your router's performance in routing, you should pay a lot of time in IP design phase and do it correctly so you could use route summarization in future. Choosing the place where route summarization should be implemented is a challenging work for network administrators, and they have to decide about it very carefully. because choosing the wrong place could consequence suboptimal forwarding situations. I will show you one of these situations in the next slide. Now we want to consider a situation where route summarization causes suboptimal forwarding path. Assume that we have 256 networks from 0 to 255 with a /24. This router and this router summarize these routes to 192.168.0.0/16. But the metric of this route is better than this one. Know that the metric of the summarized route is the best route of the summarized ones. I mean, among these 256 networks, the best metric is the metric of the summarized route. Now, this router choose this way to reach the network of 192.168.0.0/16. Assume that this link goes down. This router does not stop sending the summarized route because sending summarized route is stopped when all subordinate routes are failed. I mean, these 256 networks, when all of these are failed, this router stops sending this route. Now, this link is go down, but this router still summarize it and advertise it, and does not notify this router that this link goes down and I cannot reach these networks. Now what is happening? This router still sends packets which are destined to these networks to this router. And this router now knows this is not the path, so choose this one. And then this router choose the route to this router and we reach the network. Now you see that this router should go from this path to this router, and this router to reach the network. This router has a link to this one and could use it when this is failed. But route summarization caused that this router still sends packets to this one, and this one, and choose the suboptimal forwarding path instead of the best path. Now you see that route summarization could cause some problems for our networks. In IT world, we always confront situations that we have to choose a solution or not. In these situations, we consider the benefits and trade-off of that solution. And after that, we decide about that to use it or not. Route summarization has some costs and benefits, or trade-offs and benefits. The benefits are smaller routing tables, reduced query scope. I'm sure you remember that EIGRP has a mechanism that when a successor route is failed and there is no visible successor route, the route starts to query the neighboring routers and ask them if they could help it to reach that failed route. And if we have route summarization, when queries are received at the summarized router, the summarized router answers the query and the query does not go more in the network. Summarization could be done at any location in the internetwork. And the metric of the summary route equals the best metric of the summarized subnet. And the costs or trade-offs can cause suboptimal routing, we saw that, and packets destined for inaccessible destinations will flow to the summarizing router before being discarded. They could be discarded before going to the summarized router, but they are coming to the summarized router and then they are discarded. And we waste our bandwidth in some situations. And now this is your choice. Use route summarization or not. EIGRP auto summary. Auto summarization first arises with the first generation of routing protocols which are classful, like RIP version 1 or IGRP. In that era, auto summary feature is a required one because in those routing protocols, networks must use classful IP addresses and obey the laws and could not use VLSM because those routing protocols do not send the subnet mask of the route, therefore they could not do classless routing. But after introducing the new generation of routing protocols like EIGRP, OSPF or RIP version 2, since they could send subnet mask with the routes, they could support classless routing and support VLSM. Therefore, for example, we could use the network of 10.0.0.0/24 in our network. Auto summary still supports in EIGRP. But if you do not use the classes laws in your IP design, auto summary may cause some problems for you. Because if you enable auto summary, which is enabled by default, when a router has multiple working interfaces and those interfaces use IP addresses in different classful networks, the router advertises a summary route for each classful network on interfaces attached to a different classful network. You may confuse. I show you with an example. I use this scenario. Router 1 has 5 interfaces: fast Ethernet 0/0, 1/0, 2/0, and 1/0. They are in 10.1.2 network. Let me show you. Show IP interfaces brief. You see that they are in this range: 10.2.1.1, 10.2.2.1, 10.2.4.1, and 10.2.3.1. And the interface between router 1 and router 2 has the IP address of 172.16.1.1. And router 2, if I show IP interface brief, you'll see that it has 2 IP addresses: 192.168.1.1, 172.16.1.2. They are all in different classful networks. And the same is true for router 3. Show IP interface brief will show us that there is one network between router 2 and router 3 with 192.168.1.2. You see, I choose 3 different classes: 10 here, 172 here, and 192.168 here. I configure EIGRP on these routers all and advertises all networks. If we see the configuration on router 1, show running config, you will see the EIGRP configuration here. You see that I advertise all networks, and there is a command here, this command, auto summary. Auto summary is enabled by default, and if you want to prevent EIGRP to use auto summarization, you should say that no auto summary in EIGRP router subcommand mode. But it is enabled by default, and I want to show you what is happening if it is enabled. In router 2, if we see that show IP route, you will see that for the network of 10.0.0/8, which is the whole class, there is only one route. If your network is contiguous, I mean all the network of 10 is behind this router, everything would be okay and there is no any problem. But if your network is discontiguous, I mean you have 10.2.1, 10.2.2.3 and .4 here, and for example 10.1.1, 10.1.2 and 10.1.3 here, you could not use auto summary because this route will advertise from router 3 and router 1. And router 2 will confuse that. How could reach the network of 10.0.0.0? You divide this to 2 discontiguous part of your network, but route summarization, especially auto summarization, will cause this problem for you, and you could not do anything because auto summary will obey the rule that I told you. And in router 3, if we see the routing table, show IP route, you will see that there is only one route for 172.16.0.0/16, the whole class of 172.16, and 10.0.0.0. And if you use these networks in other part of your networks, auto summary will cause problem for you. So if you do not obey classes laws in your IP design and you use VLSM, your subnets and your networks are distributed discontiguously, you should disable auto summary with no auto summary in your network. And now if I do it, we will see the consequences. In router 1, router EIGRP 1 and I say no auto summary. In router 2, router EIGRP1, no auto summary, and do it in router 3, router EIGRP1, no auto summary. And now if we see the routing tables, we see the consequence of issuing this command. You will see that each network is advertised separately. And if you design your network discontiguously or using VLSM, you have to disable auto summarization. Now we want to configure EIGRP manual summarization. Manual summarization is very simple. It's only one command. And the more difficult part is considering the trade-offs that we talked about them before and designing the correct IP address schema. Manual summarization is done on interfaces. In this network that I use it, which are 10.2.0.0/24 up to 10.2.3.0/24. I want to advertise this route only in one route with manual summarization. Therefore, I go to Fast Ethernet 2/1, the interface which advertises these routes, and say IP summary address EIGRP, the AS number, the network, which is 10.2.0.0, and the subnet mask, which is 255, and 0. When I issue this command, you will see that our EIGRP neighborship brings down and again becomes up, and the topology informations are changed and new information are delivered to the router 2 and other routers. You will see that everything is resync. And now in router 2, if we issue show IP route, you will see that there is only one route for 10.2.0.0 is reachable from 172.16.1.1, which is the router 1. The configuration for IPv6 is the same, only IP replaces by IPv6. I mean, we issue the command IPv6 summary address, EIGRP, the AS number, and the network prefix. Everything is the same, only IPv6 substitute IP. Now we want to see some consequences on the issuing or the summarizing router. Let me clear the screen first and go to the privilege mode, and I say show IP route. You will see that here there is a network 10.2.0.0/22 is a summary, which is the next hop is null 0, which is the router itself. And I issue show IP EIGRP topology for the network 10.2.0.0/22. You will see that again the routing descriptor blocks goes to the null 0. And show IP route 10.2.0.0 with the subnet mask of 255.255.255.0 and the keyword longer prefixes. And you will see that this route is in the routing table and you could use it. Now it's summary time. In this lecture, we learned what is route summarization, what are the costs and benefits, and where we could use it. Then we learned how to configure auto summarization. We saw that auto summarization is enabled by default, but only you could use it in classful IP designs. And finally, we configure manual summarization, and we saw that we could use manual summarization in VLSM IP designs too. I hope this lecture helps you to improve your knowledge, and see you in the next lecture.